Hey everyone, this is Brendan with Cusack Prep, and in this video we're going to remind you of the Pythagorean trig identities. Not only are we going to do that, but we're going to show you why they're true, how they relate to the Pythagorean theorem, which is why they're called Pythagorean identities, and also kind of show you a way that if you know one of them, you can really figure out the rest. So the first Pythagorean trig identity is sine squared of theta, or of x, plus cosine squared of theta is equal to 1. Now, you just want to remember that. As you go further in math, you'll want to understand more and more about it, but for now, just kind of have you memorize it. Now, if we want to get to the other Pythagorean identities, what we have to do is just divide every single term in this by sine squared or by cosine squared. So I'm going to start with sine squared. So if I divide sine squared of theta by sine squared of theta, I'm going to end up with 1. If I divide cosine squared of theta by sine squared of theta, well, cosine over sine, that's cotangent. And if I divide 1 over sine squared of theta, well, 1 over sine, what's that? That's cosecant. So 1 plus cotangent squared of theta is going to equal cosecant squared of theta. And you can see how I didn't have to memorize that. I was able to just kind of figure it out by dividing everything by sine. After that, we can take a look at another one, which is what happens if we divide everything by cosine squared of theta. So if I do sine squared of theta divided by cosine squared of theta, well, sine over cosine, that's tangent squared of theta. Cosine squared over cosine squared is just going to be 1. And 1 divided by cosine squared, well, that's going to be secant squared. So this is something where you're going to want to memorize really the first one, and then how to get the second two. You'll find that as you work with them in time, you will be able to memorize them. Now, if you want the proof, some of you are probably done watching at this point, but if you want the proof for this, or if you just want to see why it's true, we can go ahead and draw a right triangle. So let's say we got this right triangle here, and I'm going to say this is a 90-degree angle, and I'm going to look at this as sine theta. I'm going to call this y, I'm going to call this x, and I'm going to call this r. Well, we can see that this sine squared of theta plus cosine squared of theta equals 1 really just comes out to be the Pythagorean theorem. So what is sine of theta? Well, if you remember, sine of theta is opposite of the hypotenuse. So in this case, sine of theta is going to equal 1. What's cosine of theta? Cosine of theta is going to be the adjacent. I'm sorry, sine of theta is not 1. Sine of theta is y divided by r. Now, what about cosine of theta? Well, cosine of theta, that's going to be the adjacent over the hypotenuse. So that's going to be x divided by r. So if we take this and we plug it into sine squared of theta, well, if sine of theta is y over r, sine squared of theta is going to be y over r squared, which is y squared divided by r squared. Cosine of theta is going to be x squared over r squared, and the right side is just going to equal 1. I'm just plugging these values into my top equation here. Now, what do we know about adding fractions? We know that you can just add straight across the top and keep the denominator the same. And if I go ahead and I multiply r squared over to the right-hand side, I would find that x squared plus y squared is equal to r squared. Well, guess what? That's just the Pythagorean theorem for this right triangle. We know a squared plus b squared equals c squared. And there you have it. That's kind of a quick and easy way to remember the Pythagorean trig identities, as well as a kind of a short little proof showing you why that's true. Thanks for watching. Hope you enjoyed this video.